This is the screencast for section 4.3, example 8. We're going to use the fact that trig functions are periodic to help us with the trig values of really large angles. Now, periodic means that every so often these trig values, they repeat themselves. And you already know that because coterminal angles have the same terminal ray. Therefore, an angle like 45 degrees and 360 plus 45 degrees and 360 plus 360 plus 45 degrees, they're all going to have the same trig values because they land in the same place as far as standard position is concerned. So if we look at the sine of 57,801, yes, that's what I'm setting, pi over 2, I'm going to split that up into something that's a little bit easier to understand, a little bit, not a lot. That's going to be 57,800 pi plus another pi all over 2. So if you have 57,800 pi plus another pi, you have 57,801 pi all over 2. Well, now I'm going to split these up so I can say that this is the sine of 57,800 pi over 2 plus pi over 2. Luckily for me, 57,800 pi over 2, well, 57,000 divided by 57,800 is divisible by 2. So this is really the sine of 28,900 pi plus pi over 2. Well, 28,900 pi is actually just only 14,450 full circles. Remember, 2 pi per circle, not just 1 pi. So 2 pi per circle. So that's 14,450 full circles that I don't have to worry about. So all I'm looking for is the sine of pi over 2, and I know that that is 1 from my unit circle. Now part B, the cosine of 288.45 pi, well, cosine's period is also 2 pi, so if I take the cosine of 288, which is divisible by 2, pi, plus another 0.45 pi, and then subtract cosine of 280 pi plus 0.45 pi, the 288 pi and the 280 pi, well, this is 144 full circles. 280 pi is 140 full circles, so I don't need to worry about those. All I'm worried about is the cosine of 0.45 pi minus the cosine of, what do you know, 0.45 pi. Well, that's going to be 0. Now tangent is slightly different because we're not dealing necessarily with coterminal angles. A tangent's period is only pi. So tangent's values repeat itself every half circle. So in this case, we have pi over 4 minus 99,999 pi. Well, since tangent's period is a single pi, these represent 99,999 half circles where tangent is repeating itself. So I don't need to worry about any of those because those are all repeating the same values over and over and over again. All I need to worry about is the tangent of pi over 4, which is 1. Then now try problem number 49. Asks us to look at the sine of pi over 6 plus 49,000 pi. 49,000 pi is 24,500 full circles. And then we'll have a pi over 6 left after that. So I'm going to look at the sine of pi over 6. And the sine of pi over 6 is 1/2.